Thank you so very much. I appreciate it very much that you have invited me to be among you, because we are mainly a very small organization which has some, I guess you would say, very large ideas. We're small because it's taken us 10 years, going on 11, to begin this program that we have, which is called the Geomagmatic Power Tube. I have to explain the word because it's not in the dictionary. We did some work for the Air Force in which they asked us to submit a package with regard to geothermal. We submitted our package, which was not exactly geothermal. It did not fit the Air Force's geothermal description. So they sent it back and they said, redo it. So I called and I said, we can't redo it because this is what we are, this is what we're doing. They said, well, call it a different name, but don't call it geothermal. I said, all right. So we looked around for a name and we came up with geomagmatic, because most of what we do depends on the magma that is a support system for the heat source that makes the power tube work. So we gave that name and they said, okay, we'll accept that, but we'll give it a number. So it's under a number now instead of a name. However, a few days ago I received a call from the Oxford Dictionary people asking to explain what that word meant, since it's only in a few places in the internet, and that's where they got my address. So I explained it to them. So it may wind up in the Oxford Dictionary, I don't know. It doesn't really matter, actually. We do what we're doing. As I said before, I've been trying very hard for a long time to put together something that I think will really help mankind. What will really help the planet and will really get power out to regions of the world that never had power before. And one of the ways that came across was the program that I had put together, because of the fact that most of the countries that need help are sitting on their own energy source, but it's not being used. And that's the magma that flows. Some of the slides you'll see, you've probably seen before in other presentations. They're generic, but there's some that are our original and only ours. I want to bring to mind the fact that when the Wright brothers were flying their first aircraft around, there was a newspaper in North Carolina with the headlines, "It will never fly." Yet there they were, flying around. So keep that in mind. The Argus A1 device is comprised of two closed-loop circulating circuits. In the first, the heat is brought to the surface from the depths of the Earth by a patented thermal riser. In many parts of the world, especially those in areas denominated as the Ring of Fire, the temperatures required to operate the power tube are closer to the surface. Therefore, in many cases, the thermal riser is not required. The required minimum temperature necessary is 300 degrees Fahrenheit or 148 centigrade. The power generating system operates at 10,000 RPM and needs only 225 degrees Fahrenheit or 108 centigrade.
The resource temperature is higher than the operational temperature when you take losses from the heat transfer into account. The heat loss is a factor when you are transferring heat from one source to another. The heat from the thermal riser is transferred to the heat exchanger. This is the start of the second closed circuit cycle. The heat exchanger contains 6,600 feet of specially designed stainless steel tubing, which contains a formula of isobutane isopentate liquefied gas. The tubes in the heat exchanger are bathed in heat exchange fluid that circulate down to the bottom of the thermal riser and returning to the heat exchange, completing a heat transfer loop. As the throttle control or valve opens to release the compressed liquids into the turbine chamber, they become a gas, which propels the turbine, which is directly coupled to the generator in the monocoque turbo generator system. This creates the power. As the gas leaves this monocoque turbo generator system, it goes through the condenser system, the first, second, and third stages. In certain cases, an additional condenser, or the SCCD, called the supercooling condenser driver, may be used. The SCCD operates by compressing a gas, much like a refrigerator works, but instead of the standard motor or turbine, it uses sound, which eliminates moving parts and requires a lot less energy. After the gases are cooled and transferred to the equalization tank, they are then pumped back to the heat exchanger, where they start their closed circuit journey again. The surface footprint of a 10 megawatt power tube is only 10 meters by 10 meters by 3 high. There is no pollution, no use of water, no aquifer contamination, and no unsightly structures, and the installation is rapid.
It is my hope, if we can eliminate the use of those gas-powered, diesel-powered units, and we can multiply those 400 tons by 500 for each plant, that's 10,000 plants. That's 40 million tons of pollution not going into the atmosphere from carbon-driven or carbon derivative-driven generators. And that's it.
Thank you, Mr. Brewington. Thank you.